Deep beneath the frozen wasteland of the Arctic Circle, explorers uncovered the fossilized remains of broad-leafed tropical plants. That discovery pairs with another geographic oddity. Look at a map of the world, and the eastern coast of South America and the western coast of Africa align perfectly, appearing as though they were ripped apart. This is a Mesosaurus fossil. The remains of this small freshwater reptile have been found on both of those matching coastlines, separated by 4,000 miles of deep, saltwater ocean it could never have swum across. The physical evidence demands an explanation that breaks conventional understanding of a static, unchanging planet. In 1912, German climatologist Alfred Wegener looked at these patterns and proposed a radical hypothesis. He argued that all of Earth's land masses were once connected in a single, massive supercontinent he called Pangea. Wegener spent his life hunting for data. He launched grueling expeditions to hostile environments, including the ice fields of Greenland, to gather the geological evidence needed to support his unified Earth theory. But the scientific establishment mocked his ideas. The missing piece was physics. Wegener's theory suggested continents plowed through the rigid ocean floor, but he could not identify a force strong enough to push a massive continent through solid rock. Wegener died on a Greenland expedition in 1930, his ideas largely dismissed. For the next 50 years, the mystery of the matching coastlines and misplaced fossils remained one of the great cold cases of science. A compelling theory without a proven mechanical engine to drive it remains speculation. Science waited for new military technology to find the hidden forces operating beneath the waves. The breakthrough arrived in the 1950s. During the Cold War, military submarines using sonar to map the deep ocean inadvertently provided the data needed to solve the mystery. Cartographer Marie Tharp analyzed that sonar data to reveal a landscape of towering mountains and yawning trenches, including a 50,000-kilometer underwater range wrapping around the globe. If you look closely at the center of this underwater mountain ridge, you'll find a giant rift running down the exact middle. This rift is an active volcanic seam. Molten magma bleeds out of the gap, cools into new rock, and physically pushes the older ocean floor outward. Magnetic striping in this cooling rock acts as a tape recorder. As Earth's magnetic field flips over millions of years, the rock preserves the changes, providing undeniable mathematical proof that the seafloor is expanding. The continents were never plowing through the ocean as Wegener thought. Instead, the ocean floor itself is expanding, acting as the mechanism that shifts the world's land masses. To see how that conveyor belt operates, we have to look inside the planet. Earth's rigid outer shell is called the lithosphere, the solid layer of crust and upper mantle, which floats on top of the deeper, flowing asthenosphere. The asthenosphere is the hotter, semi-fluid portion of the mantle that allows the plates above it to shift. The first major force is mantle convection. Earth's internal heat creates rolling circulatory currents in the asthenosphere that drag the massive plates above them. Next is ridge push. Because the newly formed crust at the mid-ocean ridges is hot and elevated, gravity causes it to slide downward and outward away from the center. Finally, there is slab pull, the most powerful force in the system. When an old, dense plate sinks into the mantle, it drags the rest of the plate along with it like a heavy anchor. These three forces combine to form a planetary conveyor belt, driving billions of tons of rock at the slow speed of a growing fingernail. Zooming out to the surface, the immense power of this internal engine becomes visible at the seams where these massive tectonic plates interact. At convergent boundaries, plates crash into one another. One plate dives into the mantle and melts, generating the magma that triggers massive, explosive volcanoes. At transform boundaries, plates laterally grind past each other. The rough rock faces snag, locking the plates in place while the mantle below keeps pushing, building up immense pressure. When that rock finally gives way, the sudden release of stored pressure violently ruptures the surface, creating catastrophic earthquakes. The deadly natural disasters threatening human cities result from the routine friction of Earth's tectonic engine operating exactly as designed. Earth functions as a dynamic, ever-recycling system, constantly reconfiguring its surface over millions of years. Wegener's Pangea represents a single phase in a repeating 500 million year supercontinent cycle, where the land masses spend eons assembling and tearing themselves apart. We can see the modern-day trajectory clearly. The Pacific Ocean is currently shrinking through subduction, while the Atlantic Ocean continues to expand. The current world map is merely a temporary snapshot. The tectonic puzzle is still in motion, and in 250 million years, it will rewrite the face of the Earth into an entirely new supercontinent.